Welcome back to the Math Society. So this week we'll be continuing on with another topic, which is surds. So let's get right into it. Okay, so for number one, it says to just express this given surd in the form n plus root n, where m and n are supposed to be integers, and you just need to show it working clearly. We know that if we have surds, we need to rationalize them, so we'll try to rationalize them first. So root 35 plus 3 root 5 minus 2 root 7 minus 6 by root 5 minus 2. So we know that when rationalizing, it's multiplying with the same set with the same denominator, but then it has to be a different sign. So you're gonna have to multiply with root 5 plus 2 by root 5 plus 2. So then let's try to multiply. You will get root 175 plus 2 root 35 plus 15 plus 6 root 5 minus 2 root 35 minus 4 root 7 minus 6 root 5 minus 6 to 12, and then you gotta multiply, so you're gonna have 5 minus 4, right? So then you will be left with 2 root 35, 2 root 35, that can be cancelled out. 6 root 5, 6 root 5, that can be cancelled out. So you will be left with 7, so that would be 5 root 7. If you change it back to root, you got a plus 15 minus 3 minus 4 root 7 divided by 1. So root 175, if you change it back, you get 5 root 7 divided by 1. So then you'll be left with 3 plus root 7. So we know that we need m and n, so m is going to be 3 and n is going to be 1, and that is your answer. And moving on to question 2, it says without using the calculator, showing your working clear, find the value of the integer a. So first we're giving these roots where we don't know like if we can multiply it and what kind of number it makes, so we're going to solve them first. So we know that root 180, that could be you gotta think about the square number. So here there's a possibility that it is 36, which is the square number of 6, multiplied with 5, so you'll have an answer of 6 root 5. And then root 27, it is, you know, that we know a square number of 9, 3 is 27, so you'll have 3 root 3. And 20, we know it is you can multiply 4, 5, so that is a 2 root 5. And then 147, so this can be a root 49 multiplied 3, so you'll have 7 root 3. And then let's just write it down again, which is 6 root 5 minus 3 root 3 minus 2 root 5 plus 7 root 3, and that has to equal to a bracket root 5 plus root 3, right? So let's try to solve this first. So we have 6 root 5 minus 2 root 5, that's 4 root 5, minus 3 root 3 plus 7 root 3, that should be plus 4 root 3, and you gotta equal to root 5 plus root 3. And in here we see that 4 is a common, so we can take 4 out, so you'll have 4 root 5 plus root 3, and that is equal to a root 5 plus root 3. So then you will get an answer of a is equal to 4. And I think they just asked you for this, yeah, integer a. So we know that a will be equal to 4. Okay, so now moving on to question 3. Without using a calculator, showing all your working, express this in the form. So we know that if it's surd, we need to rationalize it. So let's just write it down first, which is 6 minus root 8 divided by 2 plus root 8. So we need to rationalize, multiply with 2 minus root 8 divided by 2 minus root 8. So then you'll have 6 to 12 minus 6 root 8 minus 2 root 8 plus 8 divided by 4 minus 8. So then you will have minus 12, 20 minus 8 root 8 divided by minus 4, yeah? So then we can just swap it around. So it would be 8 root 8 minus 20 by 4. And then we can divide by 4. So it's going to be 2 root 8. Oh wait, fourthly we have root 8, right? So root 8 is a square number of root 4 multiplied 2. So we can have 2 root 2. So if you multiply with it, you'll have 16 root 2 minus 20 by 4. So then you can now divide by 4. So 4, 4, 16, 4, 5, 20. So you'll get an answer of 4 root 2 minus 5. So that should be our answer. And then a plus b are integer. So you have, just say a plus b root. We need to show in the form a plus b root, right? So then we need to change the form back. So for a plus b root, we know that if it's 4, it's going to be 16 multiplied 2, right? Minus 5. So that's going to be root 32 minus 5. But they gotta switch it around because it's a plus root b. So it will be minus 5 plus root 32. And that should be your answer. Always make sure to check what kind of like form that they're asking for, so you know that you're in like the right position and everything as well. And moving on to question 4, it says to express it again and we just need to rationalize it. So it's root 13 plus root 11 by root 13 minus root 11. I'm gonna multiply with rationalizing, so that's root 13 plus root 11 by root 13 plus root 11. So let's multiply it. So that's 13 plus, should be 143 plus 143 plus 11 divided by 13 minus 11. So then you should get 24 plus 2 root 143 divided by 2. You can divide it, so that's 12 plus root 143. And so let's check if it's in a form. Yep, a plus root b. We have 12 plus root 143, and it's in a form. So now we can move on to question number 5. So for number 5, it says this surd can be written in this form. Find the value of a and b. So it's the same thing. So because this gives us the square, let's just solve the square first. 1 plus root 2 square. We will solve the square first. So 2 minus root 2 by, that should be 1 plus 2 root 2 plus 2. So it is going to be 2 minus root 2 by 3 plus 2 root 2. Okay, so now we know that it is 2 minus root 2 by 3 plus 2 root 2. We can now rationalize it. So it's going to multiply with 3 minus 2 root 2 divided by 3 minus 2 root 2. So let's multiply them. So that's 3 to 6 minus 4 root 2 minus 3 root 2 plus 4 divided by 3, that's 9, 4, 2, 8. So that's 9 minus 8. So you'll have 10 minus 7 root 2 by 1. So it's just 10 minus 7 root 2. And let's see in the form a plus b root 2. Yep, a plus b root 2. So find the value of a and b. So a is going to be 10. B is going to be minus 7. And that's your answer. Okay, so we'll now move on to question number 6. So question number 6, same thing, where we just need to rationalize in the form a minus root b. So 4 minus root 12 by 4 plus root 12 multiply 4 minus root 12 by 4 minus root 12. So then let's multiply them. So that's 16 minus 4 root 12 minus 4 root 12 plus 12 divided by 4, 4, 16. That's minus 12. So you will have 28 minus 8 root 12 divided by 4. So that's 7 minus 2. And then, okay, so here we have a we have a root 12 again. So root 12, there's a square number it can be involved, which is 4, 3, 12, right? So which is 2 root 3. So then you can multiply it. So that's going to be 28 minus 8 minus 2, 8 multiplied to that 16 root 3 divided by 4. So now finally we can like simplify it. So that should be 7 minus 4, 4, 16, 4 root 3. Just always need to make sure that the number within the root doesn't have like a square or number or stuff, so that it's the most simplified version. So 7 minus 4 root 3, a minus root b. Yep, so it's in the a minus root b. Oh, sorry, a minus root b. We gotta multiply again. So that should be 4, 4, 16 multiplied 3, isn't it? So it should be 48. So that's 7 minus root 48. So if they ask you in this form, it probably shouldn't be necessary to change it back, but then as long as you can change it back at the end, it should be fine. So that's 7 minus, yep. And then we'll go on to number 7, which shows that showing on your working express this for a root a is a positive integer. So because we clearly see that 75 kind of seems like it's multiplied by a square number and one number. So we know that it's 25 multiplied 3. So it's a square number of 5 root 3. And then root 243 as well. Let's simplify it. So that's 81 multiplied 3. So that is 9 root 3. So then we have 5 root 3 plus 9 root 3 divided by root 7, right? So we're going to rationalize it, multiply by minus root 7, minus root 7. So then you shall have 5, so that's minus 5, 21, minus 9, 21, divided by 7. So you'll have minus 14 root 21, divided by 7. And that should be minus 2 root 21. And then because we only want in the form of root a, we have to multiply it back, so which is minus 4. So that's 21 multiply minus 4 again. Oh wait, sorry, 4, because it's going to be square, so that's going to be 4. So you should have 414, 428. So that should be an answer of root 84. Yep, and then moving on to number question 8, it says, here in the form of n plus n root 5, so we have 4 plus root 20 by root 5 minus 2, gotta rationalize it, so root 5 plus 2 divided by root 5 plus 2. Multiply 4 root 5 plus 428 plus 100 plus 2 root 20 divided by 5 minus 4. So you will have 4 root 5 plus 8. So that should be 10. Plus this one as well. So 2. So that's 4 multiplied 5, which is 2, which will root 20 is 4 multiplied 5, right? Which is a square. So that should be 2 root 5. So it should be 4 root 5 divided by 1. So you will have 18 plus 8 root 5. And check if it's in the form n plus n root 5. It's in the form n plus n root 5. So it should be okay. And so now we'll move on to number question 9. So given that p is equal to 1 plus root 5 by 2, show that 1 by p equal to p minus 1. So we need to make sure that 1 by p's answer is the same as p minus 1. So let's find 1 by p first. So for 1 by p, it would be reversed, so it would be 1 plus root 5. And you gotta multiply by 1 minus root 5, rationalize them. So then you should get 2 minus 2 root 5 by 1 minus 5. So that should be 2 minus 2 root 5 by minus 4. So that's 1 minus root 5 by minus 2. So then you can just form it as root 5 minus 1 by 2. And then this time we'll find p minus 1, right? P minus 1. P is 1 plus root 5 by 2 minus 1. So then it should be 1 plus root 5 minus 2 by 2. So that should be root 5 minus 1 by 2. So let's see if the answers are the same or not. Root 5 minus 1 by 2, root 5 minus 1 by 2. Therefore, 1 by p is equal to p minus 1. And that should be our answer. So now we'll move on to number question 10. So in question 10, it says, without using a calculator, same thing, should be in this form, a root 3 plus b. So we'll have to rationalize again. So 4 minus 2 root 3 by root 3 plus 1. Multiply root 3 minus 1 by root 3 minus 1. So then you'll have 4 root 3 minus 4 minus 6 plus 2 root 3. And then you'll have 3 minus 1. So we will have 6 root 3 minus 10 divided by 2. And then you just have to simplify them. So that should be 3 root 3 minus 5. Then make sure that it's in the form a root 3 plus b, a root 3 plus b. And that's in the form. So I think that's it for today's video. And I'll see you in the next video.